you lift an object, a force must be applied to lift it. But if you lift an object attached to the stick, then you have to apply the torque. Torque is not a force, although torque is related to force because it is the measurement of the effect of a type of force, which is rotational force. In particular, force is the one that causes the torque. For instance, this activity will demonstrate how force and torque differ by lifting an object attached to a stick. The materials needed for this activity are 1 meter stick, 1 kilogram mass, a meter stick clamp, and a mass hanger. Since some materials were not present, we used substitute materials such as binder clip as our meter stick clamp, nylon string as our mass hanger, and 1 liter of Tattoo soy sauce as our 1 kilogram of mass. Step 1. Hold the end of the meter stick in your hand so that the index finger is at the 5 cm mark. Position the mass hanger at the 10 cm mark and suspend the 1 kilogram of mass from it. Rotate the stick to raise and lower the free end of the stick. Note how hard or easy it is to raise and lower the free end. Step 2. Move the mass hanger to the 20 cm mark. Rotate the stick up and down about the pivot point as before. Repeat this procedure with the mass at the 40 cm mark to the 95 cm mark. As noticed in the video, upon lifting the stick, the mass moves farther from its pivot point. It will create a moment of force to lift the stick. When pulled upward, the weight feels heavier because the farther the object is, the greater the force needed to lift it. This is because of torque. As an illustration, if you want the stick to be in equilibrium as the mass attaches to it about the distance from the pivot point, a particular force must be applied to the pivot point to match the opposite force of an object that causes the stick to rotate. As we move the object from its pivot point, we felt it getting heavier than the closest distance from the pivot point as we rotated upward. Yes, when we move the mass from its pivot point farthest from the farther point, the weight of the stick also increases. Due to the increase in torque, we felt it heavier when we moved the object farther from the pivot point. This is not because there is a change in the mass of the object, but due to the distance between the pivot point and the object, as well as the force of its mass towards the ground influenced by gravity. Torque causes an object to rotate, while the force is the one that causes the object to move. Based on the observation from the activity, the mass of an object always stays the same and does not change at all. Torque is the reason why the weight of the stick changes, depending on the distance between the pivot point and the mass that is attached to it. Given the experiment, we notice how torque and force differ from each other. We notice that the force is the one that influences torque, causing an object to have an angular rotation. In real life, we can see this in different situations, like opening a door requires a particular force to open.